Hey, so I'm gonna show you how to make a video game. Well, you can see in my channel that I really love to play video games, and I play them on the hardest difficulty and everything. I like challenge basically. So, and link in the description of all my gameplays and everything. But I'm gonna show you how to make a video game. I'm gonna split it into like easy, medium, and hard. And easy is just like making a small game, something like Snake. We're gonna do it in C++, and medium is gonna be like how to use a game engine. So, how to use a game engine. Okay. Something like we'll use Unity. Unity. Okay. And I'm gonna show you how to make a 3D game or a 2D game or whatever using Unity. But before that, we're gonna do command line first. Command line game using Visual Studio and C++. If you don't know what any of that means, it's okay. Okay, you'll get to know everything. And the third one is hard. Hard is how to make a game engine. Now this is like hardcore stuff. Um, but yeah, so let's get to it. So first of all, open up your browser, internet browser, and just type in Visual Studio download. And just download Visual Studio basically. Get the free one. Just get the free one. Um, Once downloaded, just install it. Once you've installed it, I'm using 2013 here. I'm using 2013, but you can use whatever you want. Just as long as it's for personal use, so it's free. Once you're here, create a new project. Um, Click on C++, Visual C++, empty project, name it whatever. We'll say Snake Game Tutorial. Now, in this video, I'm going to show you the basics of programming first. Okay, this is like the setup video. So, yeah. Later, I'm going to show you like how to make command line games. Like we can do tic-tac-toe, we can do Snake. Something that doesn't require a lot of graphics. We will get into graphics later, by the way. This is just like starting basic stuff. Right click on that, click on add new item. Now you'll be in this page. Now I'll show you what a header file is, but let's just do CPP for now. Let's just name it main. Yeah. Here we are. Now we can code. Okay? Now the first line in a C++ program, any program, actually, well, it depends, but mostly it's hash include IO stream. IO stream stands for input and output stream. What is it? What else? I'll show you now. Do int main. This is a function that will be called when a program starts. When this program starts, let's just put something on the command line. std cout and whatever. SCD ::NL. Now if you run this, click on this play button. Let it compile and run whatever. You will see nothing. You know why? Because we didn't stop the program. Let's do get car. Now, if you run it, whatever, and then you can press enter or space or whatever, and I mean you have to press enter and it would just quit the program. Now let's talk. Okay, look, first of all, if you want to make games, you need to know a lot of math. Okay, don't let that like scare you or whatever, because once you understand the math, then it will just flow through, honestly. Okay, so let's make a small thing. Let's make a small well, it's not a game, it's like the first program thing. Let's do, okay, look, see. If I tell you to think of a number, anything, let's just say we choose 10, and then we do, oh yeah, these green things are comments, by the way. They don't do anything to the program, but they tell the programmer what each part of code does. So yeah, so let's say we choose 10, and then I tell you to multiply by 2, so that's what, 20. And then I tell you to add it to the first number that you chose. Add to first num. 10 plus 20 is 30, so 30. And then if I tell you to divide it by the first number that you chose, divide by first number, you would get 3. Now this math would work with all numbers. Like if you change this number to like 15 or something, then this would be 30, and this would be 45. 45 divided by 15 is 3, so it will always give 3. Now let's make a small program. SCD ::cout. Think of a number. Do not tell me. No. STD ::cout. Press enter when done. Okay, and then this get car would do it, and then we do SCD ::cout. By the way, I'm showing you this because this is actually used for debugging. So like if there's something that doesn't work, we print something. This is printing into the command line. So this is why I'm showing you all this. Press enter when done. Then we would say multiply the number by 2. And then we say this. Cool. And we do get car again. We just keep going. What was it? Multiply by 2, then plus. Add the answer to the first number that you chose, and then divide the answer by the first number that you chose. Cool. And then it would say reading your mind. And then it would say the answer is 3. And then just do get car. Okay, now if you run this, think of a number. Do not tell me. Well, let's think of like 5. Multiply the number by 2. That is 10. So we have 10 then. Add the number to the first number that you chose. So 10 plus 5, which is 15. Divide the answer by the first number that you chose. So 15 divided by 5, which is 3. Reading your mind, the answer is 3. Voila. Now, this is the most basic thing. This is the most basic program. So I'm going to teach you about variables now. Variables are things that can change. Okay, we can have many types of variables, like int. Int can store an integer. Integer values are numbers that don't have points, like 1.2. It's not like that. It's 1 or 2 or 3 or 5 or 10 or whatever. It doesn't have floating point. It doesn't have like dots. It doesn't have points there. So let's say int my num is equals to 2. Then if I do see out my num and do a get car, you would see 2. So that's cool, because now we can change this and it would do it for us. See, 10. And we can even do like, look, your number is see? Pretty cool, right? So we can add 2 numbers as well, just by using 2 integers. Int num2 is equals to like 9 or whatever, and then we say my num int answer my num plus num2. Okay, and then we print answer, and it would be 19, because 10 plus 9 is 19. Pretty cool, right? What if we want like numbers with dots, like floating point numbers? So let's just change this to float. Change this to float. And we can do 9.2. Change the answer to float as well. Float. And then we would have 19.2. So that's integer, float. We have Boolean as well now. Oh, Boolean is pretty cool. Bool something. Let's just, yeah, this is how you create a variable, by the way. Just the variable type and the variable name. Right? You can just do this and then just do something is equals to something, or you can just do it directly while you're doing this. Yeah, so Boolean can only take 2 values. That is either true or false. Okay? Now with Boolean you can do many things. Okay? For example, if I say, if, this is a conditional statement by the way, if and else if as well. So if something is equals to true. Now you can take this away, you can take this one away like that, but I'm just saying is equals to true. Notice how there's like two equals to sign here. Okay, that's for comparison. If something is true, then we would say std cout it is true. Yay. Cool. Now if I run this, this is false, see. So this is not correct. If this is not correct, this whole thing will not be executed. So when I press this, nothing will be there, see? Nothing would be there. But if I change this to true, this is true, yay. Now, what if this is an int something, right? Int something is equals to 2. Now, if I say something is equals to 2, then this would be true, right? This would be true. So it is true. But if I change it, if I change this to 3, then it's no more true. So it's not there. See? Now, yeah, conditional statements, you have like equals to, not equals to. This thing, exclamation mark, means not equal to. Then you have or. Okay, look. If I have another one, int s is equals to like 3, and then I say or s is equals to 3. Look, notice that something is not equals to 2. So this is already correct, right? If I change this back to equals to, yeah. So something should be equals to 2, otherwise this won't get executed, right? So this is false. But we're saying false or this thing is or s is equals to 3, which is correct. So either this or this is correct. So this will still get executed. This is not true, but this will still get executed. See? Look. If I say and, both needs to be correct. This has to be correct, and this has to be correct as well. Okay? So this is wrong. Now this won't get executed, see? Although this is correct. Yeah? So if I change this to like 3, then it would get executed because both of it are correct. Now what's cool is you can say bool here, bool results, and you can do this. You can take this, you can just put it here. That would return a Boolean value to the result. Then you can just result. So, see? And if I change this to 2, of course it won't run. See? Look, so this can get really complicated, but it's all logical, right? Let's go to loops. Now loops. We have for loop, while loop, and do while loop. I hardly use do while because most of the things you can do with for and while. What's a for loop? Well, if I tell you to print a number like std cout 1 and down. Now, if I do this, it would say 1, right? But what if I want 1 to 10? Well, you can tell me, yeah, I can like copy this and like do that and say 2 and then keep going 2, 3, 4, 5 till 10. But we don't want that, right? Because it can be variable as well. What if I want to take an input of how many numbers I wanted to print? Now, this is where a for loop comes in. This is the syntax for a for loop. For int I is equals to 0, semicolon, I is equals to... It's initialization, which is here. And then this is comparison, which is greater than, smaller than 10, semicolon, I plus plus. Now I plus plus is equals to I, like for example, if I do int I is equals to 0, then I do I is equals to I plus 1. So 1 plus 0 would be 1, right? So now the value of I would be 1. So if I do std cout this whatever, that and I, this result would be 1. Look. See? Now if I do the same thing again, I'm just doing the same thing here. It would be 2. See? So by using a loop, we can automate this for us. Look. And if I do that, and if I print I, look, see, so this is how a loop works. It would go here. It would see, okay, it's 0. And then it would check this. So 0 is smaller than 10, right? Of course, 0 is smaller than 10. So it would do this. It would do this. In the beginning, the value of I would be 0, right? And after doing this, when it reaches this last end bracket, it would do this. I plus plus is just like I is equals to I plus 1, which is like this. So I plus 1. It's the same thing. There's no difference. Okay? So in fact, we can even do that. We can even do I is equals to I plus 1 here if you want to. Okay? So it would do this. It would check if 0 is smaller than 10. It is. It would do this. Once it does this, it reaches this place. And then it would go here. The increment. It would increment. You can even do I minus 1 if you want. Okay, then it would go from like 0 to minus 1, minus 2, minus 3. I'll show you. Okay. Now if I just... And then once it reaches 10... let's just do 3 here. Well, let's just do 2 actually. Let's just do 1. Why not? Right? So is 0 smaller than 1? Yes. And then it would do this, and then it would add. So the next iteration, I would be 1. Right? So 1 is smaller than 1. No, it's false. So it just goes out directly. Look. If I execute this, I get 0. Because the value of 0, because the value of I is 0. Right? Now, if I do 10 here, it would give me from 0 to 9. Why is it 0 to 9? Because I start from 0 and I end at 9. 9 is still smaller than 10, but 10 is not smaller than 10. So this would be false on the 10th iteration. If you want 10, then you can do this. Now you will get from 0 to 10. Well, what if you want 1 to 10? Then just change this 0 to 1, right? Voila. Now, what if you want minus 1 to minus 10? So let's start from minus 1. And let's reduce 1 every time. Oops, that's an infinite loop. Why did it happen? Well, look, minus 1 is smaller than or is equals to 10, right? Yeah. Now, if I keep on reducing, next I would be minus 2. So minus 2 would still be smaller than or is equals to 10. Now, if you think of it, even if we go like minus 100, it would still be smaller than minus 10, right? I mean smaller than 10, right? So that's why that kept on executing. Now if I change this to minus 10, we would get our desired result, which it did not. Why did it not? Ah, yes, it's smaller than this. No, it has to be greater than this. Then you execute. Voila. So yeah, so that's like the basis of programming. And yeah, arrays, man. I'll show you arrays. So let's do an int array. Int array. Let's do like 3 values. What are arrays? Arrays are a list of values. Okay. For example, if I want to store something like if I want to store 3 numbers, I would say 3 here. And this is an integer, so I can store 3 integers. Example, ARR or 0. Yeah, it starts from 0 to 2. This is like 3 values. If you say 0 to 2, 0, 1, 2 is 3 values, right? Like 0, 1, 2. It's 3 values. So this is 3 here. Okay, let's do 100. Let's do ARR of 1 equals to 4. And then ARR of 2 equals to 6. Now, if I say 0 here, we know that this goes like 0, 1, 2, right? So this I goes 0, 1, 2 as well. Smaller than 2. Right? I plus 1. Okay? Now, this goes from 0 to 3, sorry. This goes from 0 to 2, right? So now the value of I would be 0 to 2. So we can just do like ARR that, and that's it. We would get 100, 4, and 6 get printed. See? What's cool is we can even do it in reverse if we want. Start from 2, greater than or is equal to 0, minus 1. It would go 6, 4, and 100. See? 6, 4, and 100. So that's arrays. Pretty cool. Right. Peace.